Okay, here's just a quick video looking at both the exponential function, that's this blue one, and the logarithmic function, that's that red one. Let's just look at the exponential function for a second. Y is equal to, say, 2 to the x. You can change that to whatever number you want, but you have to have an exponent there. So when you look at it, just a couple characteristics of the graph that we didn't talk a whole lot about. One of them is domain, and that's all the x values that are allowed to put in there. And so when you look at restrictions for exponent, it's not like if you had a square root sign. Like under a square root sign, you couldn't put a negative number, right? Because that's not part of the real numbers. So that would be a restriction on what you can put in for x. For an exponential function, there's no restrictions. So you could say that the domain, all the x values, as long as x is an element of the real numbers. That would be the domain of a exponential function. Now, the range, or the y values, when you take a look at a normal exponential function, notice that there's no y values that are negative. Like this line here comes down and gets closer and closer to the x-axis, but it'll never touch the axis, nor will it cross the axis. It just gets closer and closer. If you go to decimals and just keep zooming in as you go to the left, it gets closer and closer but never touches it. And that line, this line here, so for the exponential function, that line would be known as an asymptote. So the line y is equal to 0 would be known as an asymptote. So it's a line on your graph that your function gets closer and closer to but never touches. So that's an asymptote. It's related to the range because the range in terms of up and down for y values, I wrote that twice. Anyway, there's a restriction. It looks like you can come down to almost to 0, but you can't have a negative number. And so you would say the range are all the y values as long as y is greater than 0. It can't be equal to 0, but it has to be greater than 0. The other thing is what you could do is just into this function up here, you can plug in whatever you want there. Plug in a 4, plug in a 10, plug in negative a million, whatever. Doesn't matter what you plug in, you're always going to get a y value that's greater than 0. It'll never be less than 0. Okay, so that is the exponential function. If you look at the logarithmic function, this nice red one, you sort of see a similar kind of thing happening with that. And they're inverse functions. But it looks like the graph comes this way, and it's getting closer and closer to this line, but it'll never touch it. And so if we're talking about the domain, or the x values for a logarithmic function, it's opposite or inverse of an exponential function. So the domain would be all the x's, but in this case, the x's have to be greater than 0. They can't be equal to 0, have to be greater than 0. If you look at the range, it looks like it can go as far down that way as it wants, and it also looks like it's going up this way. I don't foresee it not going up anymore. It would just probably keep going up. So the range, you could say, is y is an element of the real numbers. So it can be any number, big or small. In terms of an asymptote, or a line that my graph or my function approaches and never touches, it would be this vertical red line right there. So a line of x is equal to 0 would be my asymptote. Okay, hopefully that clarifies a few terms, definitions around exponential and logarithmic functions.